Hello students, as you all are familiar with the spectrum of light, let us discuss atomic spectra. This you have learnt in the previous classes that when the white light from the sun is passed through a prism, then that light is split into a series of color bands, which is known as rainbow of colors. This is called as spectrum. The light spectrum having 7 colors, which are violet, indigo, blue, green, yellow, orange and red. In short, we are saying VIBGYOR, VIBGYOR. Why it happens so? Because when a light is passed through a prism, at the time red color which have longest wavelength is deviated the least, while the violet color which have shortest wavelength is deviated the most. Because of these, it split into different colors, and these series of colors bands is known as spectrum. When you observe in the light spectrum, one color is merged with the other color. As it is observed in this series, you can find that one color is merged with the other color. That means there is no gap between the colors. Such type of spectrum is called as continuous spectrum. So, we are familiar with the light spectrum, which have 7 colors, and these colors are merged with one another. So, therefore, it is called as continuous spectrum. And all sort of colors are having particular wavelength and frequency. Therefore, each colors are represented as radiation. So, let us discuss atomic spectra. What is an atomic spectrum? Let us discuss these in detail. Atomic spectra is 2 types. First is emission spectra. Second one is absorption spectrum. Let us discuss these in detail. Let us discuss first emission spectrum. When a substance is excited, for example, when a substance is heated, at the time it emits radiation. If a gas is taken in the discharge tube and when the electric arc is provided, it emits radiation. As shown in the figure, the radiation is emitted from the discharge tube containing the gas when it is made to pass through a prism. Then it is observed that we get a spectrum which is called as emission spectrum. Since the spectrum of emitted radiation of an excited substance is taken, therefore this spectrum is called as emission spectrum. But when the normal light, that is a white light which is coming from a source of light, is made to pass through a gas, and the transmitted radiation, when it is made to pass through a prism, it is observed that it gives rise to a spectrum which is called as absorption spectrum. As in the figure, the absorption spectrum is given. We know that normal light have a spectrum, that is a light spectrum, in which you can find that all colors are merged. But when you observe the spectrum, in this you can find that there are some gaps. You can say some dark color lines are there which is separating the colors from one another. So it found that when a light is passed through a gas, from this light, certain frequency of radiation is absorbed by the gas. Therefore, in the spectrum of light, we can observe that there is some gaps. This gap shows that that particular radiation of the particular frequency is absorbed by the gas. Therefore, the spectrum is called as absorption spectrum. Once again, we'll be discussing on this. That means when the light is made to pass through a gas, at the time it is the light which is getting after passing through the gas, that is called as transmitted light. When it is made to pass through a prism, it gives a spectrum. And in the spectrum, you can find that in the light spectrum, there is some dark lines. We can say black color lines, which you can see here. We get the spectrum in this way. So it shows that a particular frequency of radiation is absorbed by the gas. Therefore, such type of spectrum is called as absorption spectrum. Let us find what is the difference between continuous spectrum, absorption spectrum and emission spectrum, which is given together in this figure. In this, it is observed that when a light is passed through a prism, it gives a continuous spectrum. But the same light, when it is made to pass through a gas, then the transmitted radiation is made to pass through a prism. It gives a spectrum called as absorption spectrum. When you compare these two figures, you can find that in this spectrum, in the light spectrum, that is a continuous spectrum, in which certain black color lines are found. These black color lines shows that some of the radiation from the light, it is absorbed by the gas. Therefore, this spectrum is called as absorption spectrum. But how we are getting emission spectrum? When the gas is emitting a radiation, and that radiation is when it is made to pass through a prism, it gives a series of colored lines. You can find here there is series of colored lines. In a white strip, you can find series of color lines. This spectrum is called as emission spectrum because each and every substance emit a particular wavelength of radiation, which is given in the form of colors in the spectrum. So, in the continuous spectrum, you can find that all the colors are merged with each other. Therefore, it is called as continuous spectrum. But in the absorption spectrum, there is lines, and we can say dark color lines are there. Therefore, it is called as line spectrum. L-I-N-E, line spectrum. Similarly, in the emission spectrum also, we can find that there is lines or series of colors. We can say line of colors. Therefore, it is emission spectrum is also a line spectrum. So, from this we got an idea. What is a continuous spectrum? When one color is merged with the other color, then it is called as continuous spectrum, in which there is no gaps between the different radiation. But in absorption and emission spectrum, we can find there are certain lines in the spectrum. Therefore, it is called as line spectrum. Let us define emission spectrum and absorption spectrum. Emission spectrum is obtained when radiation emitted by the excited substance are analyzed in a spectroscope. And the absorption spectrum is obtained when white light is first passed through the substance and the transmitted light is analyzed in a spectroscope. The main difference here is One is the spectrum of emitted radiation of a substance. The other one is the spectrum of the transmitted light, which is absorbed, which is made to pass through a substance. Then it is certain radiations are absorbed and we are analyzing in a spectroscope. Then it is called as absorption spectrum. And when you observe the two spectrum, if there is bright color lines, then it is called as a emission spectrum, and if there is dark color lines, then it is called as absorption spectrum. This is an example of a spectrum for a particular element of a particular atom. The continuous spectrum, that is a spectrum of light, white light. You can find that all the colors are, one is merged with the other. So that is a continuous spectrum. And emission spectrum, it is observed that in the black we have certain bright color lines. Therefore it is the emission spectrum. And in the absorption spectrum, you can find that in the light spectrum there are some black color lines. Therefore it is an absorption spectrum. When you check for a substance, the emission spectrum and absorption spectrum are complementary to each other. That means when the light is passed through a substance, at the time it is observed that the particular series of a particular wavelength of radiation is absorbed. But for the same substance, when you observe the emission spectrum, we can find that the same wavelength of the radiation is emitted. So when you check that each lines are showing parallel to each other, that means showing complementary to each other. That means the radiation which can be absorbed by the substance, the same radiation can be emitted by the substance when it gets excited. Spectrum of a different light can be easily determined with the help of a device called as spectroscope. These are the spectrum which is observed when a different type of light is monitored with the help of spectroscope. It is observed that each element gives a unique spectrum. These are the emission spectrum of a different element in the periodic table. So when we observe closely, each and every spectrum is unique. That means the spectrum of one element does not show similarity to the spectrum of another element, because in that the lines are of different frequency which is not matches with the other. So we can say that each element gives a unique spectrum. Because of this reason, line spectrum are regarded as fingerprint of atoms. As the fingerprint of each person differ from others, similarly the spectrum, that is the atomic spectrum of each and every element, is unique. Because of this reason only, if we want to find a substance, it is of which atom, then it is easy to find its spectrum and compare with the given spectrum. So we can easily find that the substance is of particular element. So this is all we have discussed about atomic spectrum, that is of two types, absorption spectrum and emission spectrum. It plays a very important role in developing the Bohr's model. So in the next video, we'll be discussing the further details. Thank you everyone.